Hi everyone. In the previous class, we talked about digital modulations. So I hope you guys all remember what the digital means. So it's more like nowadays, digital means is everywhere. So I hope you're familiar with this, terminology. So is there anyone who remember what digital means? No? Okay, we're gonna talk about. Okay, but digital means it's a representation of signal with zeros and ones. It's only like all signals, all data can be represented with ones and zeros. So that's meant by digital. So if you have any Word files like Microsoft Office or your PPT files, those files also can be converted into digitals. So your laptop actually just store ones and zeros, tons of ones and zeros. So that's going to be a digital means. So we talk about also modulations. So modulation needs to communicate through the airs. So it's just ones and zeros cannot go through the air because it's not by just circuit voltages doesn't go through the air. So we have to adapt this circuit level signal into certain types of signals so that we can go through the air. So that's what meant by modulations. So now today we are talking about Today we are going to deal with multiple access problem. So in the previous class, what we discussed is point-to-point communications. This is simple example, just one transmitter and one receivers. So whenever you want to transmit, just transmit. That's a point-to-point communications. So in the multiple access cases, as you can notice from the multiple access, we have multiple users. Like when you think about your wireless lab, there's one access point around here, and that's going to handle all your traffics for internet. So let's say we're going to have a simple example. So there is an access point on the wall, and there are users A, B, C, D. The problem is that we have 4 users trying to access internet at the same time, but we can only accept 1 user at a time. So how can you choose which user should access the internet? So that's a general multiple access problem. It's just the same happens in your cellular network because cellular network capacity is limited. So certain amount of user can be accessed to the cellular phone system. So how do we do that? Is there anyone? What's the solution is going to be? It's very simple. No.
First come, first serve.
Yeah, that's exactly. But we need more, a few more steps to make them more accurate. So let's say A, B, C, D try to access the AP point. Then what does is that they send what they want. But if you transmit at the same time, then all the data is going to be collided at the APs. So AP cannot decode correctly because all data is mixed up. So we cannot tell which data is going to be. So what we do is that AP, notice there is a collision here, then send back to all the users. We have a collide. And what do we do next is that the feedback. and said you all collide, so I cannot tell whose data is going to be, and then said you all users should wait random time. Let's say random time for A is T1, T2, T3, and T4. If T1 is less than the others, then this timer expires first, and user A transmit, and those all three are just waiting. So now this time user A is going to access to internet. And then this keeps happening. When A is done, then all the others try to access AP point. And then they are going to, if collide, they also have random time waiting, and then choose the first one. So that's exactly what the first come, first served. But this is called Aloha. I don't know exactly what does this mean, but I have a guess. Because this multiple access protocol is actually invented by professors in University of Hawaii. But they have one access point and several Hawaii islands, and try to connect computers in these islands by wireless way, but have some kind of multiple access problem. So they come up with those ideas to figure out the problem. Now this is called pure Aloha because it's pure. There's no addendum here. But now we introduce more on the Aloha. It's called Slati. The difference is that actually user ABCD always can transmit at any time. But what we add here is we separate the times in slot. So only users can transmit at the beginning of the slot. So that's going to increase the number of, reduce the probability that they have collisions. So it's more like improvement of Aloha. So today we talk about introduction of multiple access. So we are going to talk about more practical multiple access schemes next class. Yeah, thank you.